Hello geometry students, welcome to lesson 3.5 as we talk about proving lines are parallel, how we can do that, how can we go about proving lines are parallel. So some things we should be familiar with, or things that should sound familiar from previous lessons, corresponding angles, alternate interior angles, exterior angles, and consecutive interior angles. We're talking about the converse of those things here. So what's that look like? Let's dive right in and see what we got here. So for this first one, I'm going to say this one's going to be the corresponding angles, and I'll abbreviate that like so. The corresponding angles converse. Over here, the alternate interior angles converse. Down here, alternate exterior angles converse. And then finally the CIA, the consecutive interior angles converse. And I say converse, and you should be thinking, boy, that sounds familiar. What chapter was that? That was just one chapter ago, chapter 2, talking about conditional statements, the inverse, the converse, and the contrapositive. So we're applying that here in this lesson. So if you have, before we had parallel lines to start, and we proved that corresponding angles based on parallel lines were congruent. We're talking about the converse, so we're switching the statements around. That means if you have corresponding angles that are congruent to start, I'm going to get out a different color. I would highly recommend that here. So put this in your normal color, and then if this is true, therefore these lines would be parallel. So it's just the reverse of what we talked about before. Before we started with parallel lines and said based on that the angles were congruent. Now we're saying the angles are congruent, and based on that the lines have to be parallel. So this is another way to say that. So if you have congruent corresponding angles, if this statement is true, that implies that the lines are parallel. You have parallel lines. So if you want to say corresponding angles converse as a justification for what you are doing, you can say that phrase itself. If you wanted to say this whole thing, congruent corresponding angles means you have parallel lines, that would be fine as well. So let's go here, alternate interior angles. I could say that's this one and this one. That would be one pair of alternate interior angles in there. If that's true, that implies that the lines also are parallel. So in an abbreviated form, congruent alternate interior angles, this being true means that you also have parallel lines. The same applies to alternate exterior angles. So if this one, for instance, was congruent to this one, or I could say this one to this one, that's another pair, excuse me, then these two lines have to be parallel as well. So it's the same thing now with alternate exterior angles. If these are congruent, that means you have parallel lines. And then CIA, I saved that one for last. That's the sneaky one. So these other ones congruent, congruent, congruent. But now CIA, this one and this one are CIA. Notice I purposely didn't put congruent markings on those because they're not congruent. CIA are supplementary. So these add to 180. If this is the case, if you start with that information being true, or in other words, that you have supplementary, which I'll abbreviate like that. Complementary is 90, supplementary adding to 180. Supplementary consecutive interior angles. If that's the case, that implies you also have parallel lines. So I'll put that in red. So the blue stuff being true means the red stuff also has to be true. And I'll just put my arrows over here. It still means they're parallel right there. So let's check out an example where we utilize this information to actually solve a problem. Oh yeah! What's up, vector? How you doing? So a vector is something you'll learn about. I believe you'll first learn about that in Algebra 2 if you haven't learned about it already. But hey, just throwing that in here. I like to incorporate other stuff other than geometry into my lessons here. So a vector is, well, he's somebody that commits crimes with both direction and magnitude, a direction and magnitude is all about vectors right there. Oh yeah, oh yeah, oh yeah. In the figure below, segment RV bisects ORE, angle ORE. Determine which lines, if any, are parallel. So if this is true, if this bisects ORE, then in the picture, I can say that this would have to be true. I can prove that this is true. So I'm going to get out my red, my other color, and say some extra things in the picture based on information that is given to me. So I know that this would have to be true. Why is that true, you might ask? Well, here's angle ORE, and if RV is an angle bisector, that and that have to be the same. So this one I could say is true by the definition of an angle bisector. And I've got a triangle right here. I know this is 60, this is 55. That means 180 minus these two would have to be what's left over for right there. The angles in a triangle add up to 180. So I can say that this is true because angles add to 180 degrees in a triangle. And so now I look at this picture and I try to determine what I can say now. So this was given stuff. This was stuff I could prove based on the given information in this picture. So I see right here and right here. These are potentially parallel lines, CT and OR. They look like they're parallel. They're drawn to look like that on purpose. However, this angle and this angle would have to match up if they're actually going to be parallel. These are alternate interior angles with respect to this transversal right here. If they don't match up, that implies the angles are not parallel. Right here and right here, we have corresponding angles with respect to this transversal and these two potentially parallel lines. Since these two are the same, that means these two lines would have to be parallel. So I could prove that this is true right here and right here, but I could not prove that this line is parallel to that line. So let's write that information down. We have that VE, line VE, is in fact parallel to line CT by, and what's the reason there? Corresponding angles congruent implies that you have parallel lines. That's right here. That's the corresponding angles converse. So I can say the corresponding angles converse if I have to give a justification. And I'll just abbreviate converse like that. And then from there, what else did we say about these two? We said they weren't parallel. Let's just give that reason. Let's write that reason down here. So since angle ORC, another movie reference there. Got Despicable Me, got Lord of the Rings. Angle ORC and angle RCT, this one right here, the 60-degree one. Since these are not congruent, they're not congruent. I should go a little farther with that and say they're not congruent alternate interior angles. So this one and this one, they are alternate interior angles, but they're not congruent alternate interior angles. That means line CT and line OR are not parallel. So it looked like maybe all of them were parallel, but in fact only this one and this one, based on the given information, would be parallel. Let's move on. Oh yeah! Oh, what's this movie reference now? Hey, look, it's the original Dumb and Dumber. 7-Eleven, that's coming over here. We'll get to that one in a second. But example 2, in the figures below, find X so that L is parallel to M. So now we're saying, okay, to make these parallel, this one and this one would have to be, well, what kind of angles are they? Alternate exterior angles is what we have here. And alternate exterior angles would have to be congruent if these lines are actually going to be parallel. So therefore, we could set up this equation. We could say that, 3x minus 30, that's a 30 right there, would have to equal 2x plus 20. And that's based on alternate exterior angles. So they would have to be congruent for the x's or for the lines to be parallel. So if they're congruent, what does x equal? Let's figure it out. That's what we're doing here. We're just solving this algebra problem. So I'm going to subtract 2x from both sides. I'm going to add 30 to both sides. And that'll give it to me. I'll have x. This will cancel. This will cancel. X equals 50. Nothing else to do on this one. It didn't ask you to find what the angle measures were. We could very easily by just plugging those back in. 3 times 50 minus 30 is 120. 2 times 50 plus 20 is 120. That's a good way to check our answer there. We know we did it right then. So that x value would make these two angles congruent, and those two angles being congruent, therefore, would imply that these two lines are parallel. So we've done that. We found x, so that L would be parallel to M. On this one, these are CIA. These are consecutive interior angles. So that's the one where they're not congruent. So this one here, they had to be congruent. These ones have to add right here and right here. These have to add to 180. Or in other words, these two are supplementary. So we could set up this equation for this problem. 7x plus 11 plus 11x minus 7 would have to equal 180 degrees. That would be CIA. And let's combine like terms here. It looks like we've got 18x plus 4 equals 180. If I subtract 4 from both sides, and then I'll divide by 18 for that last step, I'd get 18x here equals 176. And dividing by 18, I can reduce this fraction. 18 doesn't go in a whole number of times here, but I could divide both by 2 at the very least. This means x would equal 88 over 9. Now you're probably not going to say that in the context of the problem. You might, but 88 over 9, or you could say as a mixed number, 9 goes into 88 and 9 whole times with 7 left over. So both of these answers I'd say would be acceptable. Don't round that decimal off unless it tells you to in the problem though. So this would be an exact answer, and so would that. If you plug those back in and you work it out, this plus this would end up being 180, a way to check your answer. So this being the case, these two adding to 180 based on this x value would mean that these two lines would have to be parallel if x was equal to this, what we see down here. Well, see you later, Jim Carrey. Lloyd Christmas. Oh, that movie is something else. It's definitely got some funny moments, that's for sure. Austria. Well, good day, mate. Let's put another shrimp on the barbie. Ah, boy. Oh, dear. Oh, dear. Oh, dear. All right. Statements. Example 3. What do we have going on here? Given to prove. We have a proof here. So I'm going to show you how we could prove, using a 2-column proof format, how we could prove that this would have to be true based on this given information. So let's, with our normal color, draw in the given information on the picture. I'm using blue for my normal color. You're using a pencil, I hope, in case you make mistakes. But whatever your normal color is for notes, 1 is congruent to 2. So I'm going to put that one and that one are congruent in my normal color. So I'm starting with this stuff being true. And it's also true that P is parallel to Q. So here's P being parallel to Q. 2 single arrows on each line, or a single arrow on each line designating that. So we're trying to get to say in the end that this is parallel to this line. So based on this information, where could I proceed from here? Let's write down our steps as we go. So the steps, we want to start with the given information. That's your easy step 1. It's always your step 1. Start with the given. P is parallel to Q. Angle 1 is congruent to angle 2. Why is this true? It's true because it is a given. Step 2. So based on that, I could set up an equation. I could say that because these two lines are parallel, I know that this one and this one would have to add up to 180 together. the measure of angle 1, in other words, plus the measure of angle 3 would have to equal 180. Why is that true? Well, these are complementary. I keep saying complementary. These are consecutive interior angles. They're not complementary. They're supplementary. They're supplementary because they're consecutive interior angles. These lines being parallel implies that these two have to add up to 180. That was just CIA. So if that's the case, I'm going to put that in now using my different color. Notice here, this one and this one have to add to 180. And this was my second step. That was my step 2, so I'll put a little 2 there next to that. That was this step right here. Now, based on that information, and based on the fact that 1 is congruent to 2, I can proceed from here. Let me show you what I'm thinking next. So the measure of angle 1, if these two are congruent, has to equal the measure of angle 2. And if that's true, or why is that true? It's true because that's what congruent angles mean. It means they have equal measures. This is a definition of congruent angles. And then step 4, well, if I look at this here and here, I notice I have the measure of angle 1 in both places. And if the measure of angle 1 equals the measure of angle 2, and I have the measure of angle 1 right here, I can replace the measure of angle 1 with what it equals, the measure of angle 2. And looking at the picture, that would be really nice to be able to say that 2 and 3 add together to get 180. Because if I knew that was true, then I would have consecutive interior angles with respect to M and N and transversal P that would be supplementary, meaning based on the complementary, on the consecutive interior angles converse, that these lines would have to be parallel. So CIA converse would imply if these add to 180, which we're showing right here in this step that they in fact do, then we can tell for sure that the lines are parallel. So what allows me to do that, to replace something with what it equals into another equation, that's just substitution. So substitution, if you wanted to get fancier with that, you could say substitution property of algebra or substitution property of equality, something like that would work. But then from there, so now I've said that this one and this one add to 180. I've said that in step 4. Now I could say that step 5 would mean that this line is parallel to this line. I've proved beyond a shadow of doubt that these two have to add up to 180 based on the original information and based on the picture that I'm given here. So in step 5, we can say this is the case, that this line is parallel to this line, which is what we were trying to prove in the first place, that M is parallel to N by the CIA converse. So you asked me to prove it. I did just that. We just proved it. That'll do it for this lesson. Hopefully you found that helpful. You hopefully will remember that when you're dealing with the converse with these things, that if you have the angles being congruent here, here, or with CIA being supplementary, that means you can prove the lines are parallel. That's the big thing we're trying to do in this lesson. That's the main idea, the main concept. So go back and review as needed. Remember those things. Remember what these things are. The parallel postulate, corresponding angles converse, AIA converse, AEA converse, CIA converse. If you got that down, you are all set to go with this lesson. Hope you have a great day, and I'll catch you guys later.